Hey there, Algebra. We're doing lesson 11.6 today, one of our last algebra lessons, one of your last math grade lessons ever, for some of you as 8th graders. Eli, you got another year yet, but here we go. We're going to be adding and subtracting rational expressions. So just like when you're adding and subtracting fractions, right, you can't add them until their denominators match. So we're going to talk about how to make denominators match in rational expressions today, but the good news is a lot of them you don't have to worry about that. Take a look. Notice our denominators match in this one, so we can just add these up and keep the denominators the same like we would normally do with fractions, right? And then you're going to notice that some of these can be reduced down a little bit. Here's what I mean by that. Notice on that numerator we can divide out of 5, right? And that would leave us with n plus 3. And then notice we can cancel out a couple things, so our final answer ends up just being 5 on one like this. Here would be another example. Notice again, denominators are the same. That's the nice thing about a lot of them today is don't have to worry about that. Just keep that the same. And then we can add these up because they have matching variables, right? So we get 13c over 6, and that's nothing we can reduce or break down at all. So there we go. Notice this next one, same thing. Denominators are the same. And so we're just going to keep our denominator 3 plus y, right? And then notice on top, we'd get y squared plus 3y. If I put that together, and notice this is one we can break down a little bit because I can divide a y out in my numerator, right? So if I do that, I end up with this, right? And notice that's the same as this. This is really y plus 3 on the bottom, right? And so that can cancel out, which just leaves a y. So at the very end, always check your numerator, and if you can divide something out, do it. And chances are you can then cancel some things out and reduce it down like we just did there. They're also going to have you subtract using rational expressions. Notice, again, denominator is the same. Sweet. There's nothing we have to do with that. And then notice we're taking 3m minus 4m. So we get negative m, right? And then negative 5 take away 2, right? So in other words, minus 7. And then that would be our final answer. There's nothing else we can reduce down from there. Take a look at this next one. Okay, again, same denominator. Awesome. We can just leave that as is. And then notice we can have 17h take away 2h, which gives us 15h. And then we have 4 take away negative 6, so minus minus. So in other words, 4 plus 6 plus 10. Then notice both in the numerator and denominator we can divide some things. Notice in the numerator we can divide out 5, so let's do that. We get 5, and then we have h plus 2, right? And then on the denominator, 3h plus 2, my apologies. In the denominator, we can also divide out 5, and then we end up with 3h minus 1, right? And then notice the 5s would cancel out, and so all you're left with is 3h plus 2 over 3h minus 1, and that's your final answer. So what happens if your denominators are opposites of each other? Notice these are really opposites. We call them inverse denominators, right? And so to make them the same, we're going to take everything on the second one times negative 1, right? Everything. And so this becomes 3n minus n minus 4 stays the same. And then this other one becomes minus 6n and then n minus 4, right? Because this negative n would become positive and this 4 would become negative, right? So now we can do it. Notice, our denominators match, and so we just leave those be. And then 3n take away 6n gives us negative 3n. And that's our final answer. So if you do notice that your denominators are opposite or inverses of each other, just take one of them times negative 1, and then they'll match. And then you can do your math. Okay, but some problems are not going to have denominators that match. And so just like when you're doing, when you're doing fractions, you want to find the least common multiple. Like if I wanted to add these two up, I want to know what's the least common multiple of the two. And in this situation, it would be 30. I'd make them both 30, right? And then this would be 6 over 30. Then I could add them, right? So we're going to do the same thing except with polynomials. Okay, so take a look. Take this first one. This first one, if we broke it down like using a factor tree, we'd get this. And if we broke down the second one, we're kind of pretending like these are the denominators of a couple rational expressions, right? And so what's the least common multiple? What you would do is you use each factor the most number of times it appears. So 2, notice the number 2 appears 2 times the most, okay? So that's how many times it appears. Notice the factor 3 appears 1 time, and the factor x appears the most 3 times, okay? And so then notice our our least common multiple of these two would be 4 times 3 is 12, x to the third. All right, so if we wanted to find the least common multiple of these two polynomials, I'm just going to factor them out, right? This is n plus 1, this one on the right. And in this one, if we factored it out, it would be n plus 4, n plus 1. So notice these are all our factors, and so what would the least common multiple be? Each factor, the greatest number of times it appears. So n plus 1 appears twice in this one, so we got to use it twice. And n plus 4 appears once in this one, so we got to use that one. So our least common multiple is this. Okay, taking that skill then, let's add some expressions that have unlike denominators, okay? Notice this denominator is factored already, so I'm just going to list that right here. This one we can easily factor. This could be like t minus 3 and t plus 1, right? Would give us that, okay? And so notice, what is our least common multiple then? Our least common multiple is t minus 3 and t plus 1, right? It's got to be, because each of those appears once in at least one of them. So we need both of our denominators to be this, our least common multiple. Notice this first one already is that, so we need to make this one also match. So notice what it's missing. It's missing this. So here's what we're going to do. Let me resize here. This one can stay entirely the same. We're not going to change this one's common denominator. So I'm just going to rewrite it exactly the same right here. T minus 3, t plus 1. And then we're going to add this side, but we're going to take this side times t plus 1. We're going to take both the top and the bottom times t plus 1. T plus 1. There we are. So our top becomes t plus 1 times t plus 1, right? And our bottom becomes t minus 3, t plus 1. Okay, now that our denominators match, we can combine them together. So what we're going to want to do is we're going to want to do the FOIL method on the top here. I'm just going to rewrite this one on the left over here so we don't get too messy. First, outside, inside, last, right? So first would be t squared, right? Outsides plus t, insides plus t, and lasts plus 1. So notice we end up with t squared plus 2t plus 1. And again, our denominators were the same, right? T minus 3 and t plus 1. So now we can add them together. So notice we have no t squared on this side, so t squared. We have 2t plus 3t plus 5t. And we have 2 plus 1 plus 3. And then our denominator stays the same. T minus 3, t plus 1, and there we are. Whew. So there's a good number of steps to do this, but hopefully that made some sense. Basically, we found what our least common multiple was, and then we looked at our two denominators, and we had to fix this denominator by multiplying it times the missing piece from the least common multiple. Once we did that, we did the FOIL method to make our numerator match on this right one with the one on the left so they could easily be combined. We combined them, and we've got our final answer. There's a number of steps there. Let's do one more. All right, notice that these numbers have different denominators, right? So we're going to think through. If we factor this one, we get b. If we factor this one, we get b plus 1. Now, those are separate factors. So to find the least common multiple, we multiply each factor that appears as many times as it appears, at the most in either one. Now notice this is separate from b because this is b plus 1. That's a separate number, right? So I'm going to multiply those together to get my least common multiple, and I get b squared plus b. See how I got that? This one factored was b. B appeared once, and b plus 1 appeared once, so I have to use them both once in my least common multiple. Okay, so here's my least common multiple. So now I need both of my expressions up here to have that as a denominator. So let's start with the first one, b plus 3 over b. How can I make that have a b squared plus b denominator? I would take both the numerator and denominator times b plus 1, wouldn't I? Right? And so notice what I'd have on this first one. I'd have, notice my denominator would be b squared plus b, okay? And then I have b plus 3, b plus 1, okay? So there's our first one. That one's done. Let's focus on this one. So this one had b plus 1, so clearly I just need to take it times b, right? So let's do that. Let's do b minus 5, b plus 1. We're going to take it times b over b. And that gives us b squared minus 5b. And and b squared plus b. So let's put those two pieces apart from each other. We have b plus 3, b plus 1 from our first one, over b squared plus b, plus b squared minus 5b over b squared plus b. So let's put these together using FOIL. I know this is getting longer. There's a lot of steps to these. Firsts, right? B squared outsides plus b insides plus 3b lasts plus 3 over b squared plus b. Plus, this one's already okay, over b squared plus b. Okay, now if I combine these two middle pieces of this first one, I get 4b, right? Okay, let's combine the pieces that we can then. So we add them up and we get 2b squared, right? We have 4b and minus 5b minus b plus 3 over b squared plus b. And we're done. So good number of steps. So just to kind of repeat what we did, right? We found what the least common multiple was by multiplying the two factors together, right? Here we did that, we got this. We took both pieces times what they would need to have that least common multiple. Like this piece was missing b plus 1, and this piece was missing b. Then once we had matching denominators, we FOIL method this first one so that we could work with it better, right? First outsides, insides last. And then we added together the pieces that we could and kept our denominator the same. So I know it's a lot of steps, but hopefully that makes some sense. If you need help on any of those, or you want me to walk you through a couple more of those that have denominators that don't match, don't be afraid to ask. I'd be happy to talk you through some more. But hopefully this video helps at least make it somewhat familiar to you, and I'm here to help you if we need it, okay? Have a good day, guys. Second to last math lesson of the year. We're almost done.